Alright guys, so let's do these notes. Basically, calculus, this is going to be our intro to vectors notes sheet. So a few things that you have to remember is that what is the definition of scalars? So basically, scalars is going to be only the magnitude. So for example, on your speedometer, it basically tells you how fast you're going. So that's a scalar. But if we're concerned with both the magnitude and the direction, then we have this thing called a vector. Okay, remember Despicable Me? The guy's name is Vector instead of Victor because he has direction and magnitude. Alright, so to reiterate, with a scalar, only magnitude is important, but with a vector, both magnitude and direction is important. So there are many ways to represent vectors. We will learn several. Of course, you've already talked about the geometric interpretation, and you know that the head and then the terminal point, so we have the head and the tail. So the head is basically where it is going towards. The length of the vector is the vector's magnitude, and the direction is the vector's and the vector points is the vector's direction. So two vectors are equal if they have the same magnitude and same direction. So I'll give you guys time to kind of go through that and really interpret it, but a lot of it is just review and the definitions of what vectors are. So component form of a vector. Our component form of a vector says if v is a vector in a plane equal to the vector with the initial point 0, 0, that means that the vectors starting at the origin and the terminal point is going to be called v1, v2, wherever that is going to be. Then the component form of v is going to be written as so. Okay, it's going to be written kind of like a point, but you have, instead of parentheses, you have these pointy arrow thingies. Where numbers v1 and v2 are components of vector v. They are basically the horizontal and the vertical components. They are telling us how far right and how far up the vector is going. So v1 is going to be your horizontal component and v2 is your vertical component. And you guys remember that the vector 0, 0 is called the zero vector. So in our first example, okay, in our first example, and just really quick before I move on, if you guys remember, to get our component form from a vector that's starting at 0, 0 to v1, you know that you do, for the horizontal, you do change in the x component, and then here it's going to be the change in the y component. Okay, and it's always going to be your terminal minus your initial parts of the vector. And so let's look at our first example. So let A be 0, 0 and B be 3, 4. So A is here, B is going to be 3, 4, and then C is going to be negative 4, 2. And D is going to be negative 1, 6. So basically what you want to do is that you're going to show that the vectors u, and the vector u is from A to B. So here's A, that was C, that was D. So here's vector B, and vector u, and here is vector V, and we want to show that they are equal. So basically what we want to do is we want to combine these two vectors. We want to figure out the component form of each of these vectors and see if the component form is equal to each other. So if you remember that the component form tells us the horizontal and the vertical steps, and if we basically take the terminal end of the vector minus from the initial end of the vector. So for AB, it's going to be 3 minus 0 because it's the change in x, and then 4 minus 0 because it's the change in y. So our component form is 3, 4 from the origin. Now this one is not starting off at the origin, so the numbers are a little bit different, but from CD, that vector, the component forms are going to be -1 minus -4, the change in x, terminal, minus the initial, and then the change in the y is going to be 6 minus 2. So this component form actually ends up being 3, 4. So they are the same. Which means they are equal. Alright, I'll let you guys read about the vector notation, but basically notation could be like this or like this, represents the length or the magnitude of the vector AB. So I'm not going to read this. You will read this on your own to kind of make sure that you understand what's going on. But a vector with an initial point at the origin is said to be in standard position. So this one right here was in standard position, but this guy was not in his standard position. Okay? So the magnitude of a vector. How do we find the magnitude of a vector? The magnitude, or the length, of the vector, of a vector AB, is determined by the A, the initial, and the terminal end of the vectors. This is the notation for magnitude, so you can write it either way. But really, how do we solve this? Is this formula right here. So depending on where you're basically taking your first vector component, your V1, and you're squaring it, and then your vertical component, and you are squaring it. Okay? So let's find the magnitude of U, which is 7, 2. So the magnitude of vector U is going to be, this is a vector. This is not 2 points, so it's giving us the vector. So basically it's going to be the horizontal component, which is 7 squared, plus the vertical component, which is 2 squared. And then that will give us the square root of 53. And that's our magnitude. Next up, let's find the magnitude of AB if A is 1, 2 and B is at 5, -1. So here, they're not giving us the vector, they're giving us the 2 points. So our 2 points are going to be from she's upstairs. Yeah, in the computer labs. Sorry. So Zacky's at the door and he's not leaving. Not gonna open. Alright, so 1, 2, and then B, so that's A. And B is at 5, -1. And this is going to be, B is going to be our terminal, and this is going to be our initial, so our vector is heading this way. That's the direction. So we want to find the magnitude of this vector. So here, we're going to actually use the first part of the formula. Okay, we have to find the vertical and the horizontal components. So basically, the magnitude of vector A is going to be terminal minus initial, so 5 minus 1 squared, terminal plus terminal minus initial squared. So this is actually going to be 5 minus 1, which is 4 squared, and that's 16, plus negative 1 minus 2, which is negative 3 squared, is 9. You get square root of 25, which is 5. Alright, a unit vector is a vector whose magnitude is 1. To find the unit vector in the direction given, divide each component of the vector by the magnitude of the vector. So to find the unit vector, let's call it U. And V can't be 0. If the vector V is not 0, then the unit vector in the direction of V is given by this formula. So find the component form of the vector with the initial point. So the first thing we're going to do here is we're going to find the component form with the initial and terminal are these 2 points. So first off is the component form, which we know is terminal x values, so negative 5 so it's going to be negative 5 minus 4 minus 3 minus negative 3, sorry, I'm losing my train of thought, and then terminal y, which is 2 minus 4. So we actually end up with the component form of negative 5 plus 3, and that's going to be negative 2, and 2 minus 4, which is negative 2. Now, the length of the vector, aka the magnitude, is going to be found using our magnitude formula, which is the square root of the horizontal component squared plus the vertical component squared. So you get the square root of 4 plus 4, which is the square root of 8, and you can simplify that down to 2 square root of 2. And then, now that we found these 2 parts, we are able to use those 2 parts to find the unit vector in the direction of the vector from P to Q. So to find the unit vector in the direction of V, we're going to use this formula. So U is the vector, negative 2, negative 2, divided by the magnitude, which is the square root of 8, or you can use this, it depends on, we're going to simplify it at the end anyways. So basically what we are going to be doing here is we're just taking 1 over square root of 8 and we're going to multiply it in to these 2 components. So you're just going to multiply, distribute. So here our unit vector, whose magnitude, how this vector can be equal to 1, is that if its components are going to be negative 2 over square root of 8, negative 2 over square root of 8. And of course you can rationalize the denominator, but for time's sake, I'm not going to do it. right now to get your final answer. All right, finding the component form of a vector with a given length and direction. So in general, for vectors, v being AB, A, how you find the horizontal component, you can find the magnitude of the vector times cosine of theta. That will give us the horizontal component. And to get the vertical component, you take v times sine of theta. These come directly from the right triangle and trig. So if we had a vector, let's call this our vector magnitude right there. Basically, the way that we figure out our horizontal and our vertical components is that if we know what theta is, we can figure out what b is, our vertical component, and what a is, our horizontal component. So using SOHCAHTOA, to figure out a, we have this given guy right here. So it's adjacent over hypotenuse, so it's going to be sine of theta equals a over v. Rewrite this, right? Multiply both sides by the magnitude, and you get v times sine of theta equals a. Dude, I just said adjacent and I wrote sine. Sorry. That should have been cosine and cosine. And then for b, it's opposite. So it's sine. So it's sine of theta is equal to b over hypotenuse. Move over the magnitude or the hypotenuse, and you get v times sine theta equals b. Okay? So that's where these two formulas came from. So now let's find the component form of the vector v. The length is 3, which basically means that our magnitude of this vector is 3, and it makes an angle of pi over 4. So this is telling us that theta is pi over 4. And it's with the it makes a pi over 4 with the positive x-axis. So if I had to draw this so I can see what I'm doing, it makes a pi over 4 with the positive x-axis, so on this side. So it's a pi over 4 is about right there. And the magnitude is 3. So the question is now, what is my horizontal component and what is my vertical component? What is A and what is B? So to find A, we're going to use this formula. And the magnitude here is 3 cosine of pi over 4. And then to find B, it's 3 sine of pi over 4. So cosine of pi over 4 is square root of 2 over 2. So 3 times square root of 2 over 2. And that is your A. And B is going to be the same. 3 square root of 2 over 2. So my horizontal and my vertical components, given my magnitude and my angle, are 3 square root of 2 over 2 and 3 square root of 2 over 2. Alright, so operations using vectors. I'm not going to do these. I expect you guys to do this. This is way too easy. And I'm getting close to 20 minutes in the video. I don't want this video to be super long. But if you have two vectors, you know that the 0 vector, both components are going to be 0. You end up with 0 once you combine them. If you want to add, you just add them together. You add the u1 with v1, u2 with v2. You want to subtract, you subtract. If you have something that you want to multiply, then you know you're going to be distributing. If k equals -1, it reverses the direction of the vector, resulting in the opposite vector of the original. Whenever you add or subtract vectors, the resultant The result, sorry, is called the resultant vector. So when you add or subtract vectors, it's asking you to find the resultant vector. So I'm going to let you guys do this example with this U and this V, complete A, B, and C. And I'm going to let you guys also sketch the indicated vector using these two vectors on your page. So this is A and this is B. And you're going to sketch it. I'm just going to show you example 1. Basically, take A and B and just sketch them together, and when you are adding, you are asking to find the resultant vector. So here's A and here's B. So when you are adding, what are you asking to find? A plus B. That's our question. Okay. If you're doing 2A, then you're going to take these two and you're going to basically put them right after another, and that means the length of this is going to be our 2A. Okay, so I'll let you guys finish the last two. Alright, multiplying vectors is not something that's intuitive. So basically, it's similar to multiplying vertices. There are two ways to multiply vectors. We're going to learn one called the dot product. The second one is called the cross product, but we're not going to do it now. We're going to focus on the dot product. The dot product of vectors is if you have a vector 1, vector u with these components and a vector v with these components, you're asked to find the dot product if you denote it as u dot v. And basically when you see this notation, this is what you are asked to do. You are asked to find the magnitude of u, the magnitude of v, and multiply by cosine of theta. Another way is you take u, multiply it by v, and u2 multiply it by v2. So there are two ways to do it depending on what information you're given. So I would use this if I was asked to find the dot product of this example, because I'm given the length of v and the angle. Now of course I'd need another vector, but you see what I mean? Why we would use this compared to using this. So let's look at some examples. Oh, if theta is an angle between the non-zero vectors u and v, so if theta is the angle between the non-zero vectors, then you can figure out what theta is using inverse theta and the inverse cross product. So note, if two vectors are perpendicular, their dot product is 0. And I know you guys did this in 10th grade for sure, and in physics. Alright, so here, find the measure of the angle ABC determined by these vectors. So we have basically by these vertices, sorry. So here is what we got. We got 0, 0, that's A. And we got B is at 3, 5. And we got C, which is at 5, 2. And right now what we want to do is we want to find the measure of this angle. So we want to know what the measure of that angle is. So because we want to find the measure of the angle, we're going to be using this formula right here. which says that the theta, the angle, is going to be the inverse cosine of the first vector times the second vector, the dot product, sorry, of the two vectors, and then over the magnitude of vector 1 times the magnitude of vector 2. So in order for us to plug in those numbers, we obviously need to figure out a couple of things about this problem. Okay? Now, to get u times v, we need to do u1 times v1 plus u2 times v2 based on the formula. That's the dot product. And here our two vectors are obviously AC and AB. Oh, okay. I drew this completely wrong because these are the vertices, but we want to find the angle that is actually... Okay, I drew this wrong. And now I'm 26 minutes into the video. We want to find the angle for angle B, and I put the theta under A. So our vectors are completely going the wrong way. Alright, I'll let you guys attempt to finish this. If not, this will be in the next video. Just because we're getting close to the end. Okay, enjoy.